Hello everyone. In this video, we are going to work with the normal distribution. Let us look at the question at the top. Suppose the annual rate of return on stock indexes is approximately normal. Since 1945, the S&P 500 stock index has had a mean yearly return of about 12%, with a standard deviation of 16.5%. The market is down for the year if the return on the index is less than zero. The question is, in what proportion of years is the market down? To get started, let us draw a normal distribution bell curve. The peak of the distribution represents the mean. Let us give it a name. Let us call it mu, which in our case is equal to 12%. We know that on either side of the mean, plot the standard deviations. So this point would be one standard deviation to the left of the mean. This one might be two standard deviations to the left of the mean, and this one would be three standard deviations to the left of the mean. Likewise, we would have standard deviations plotting on the right hand side of the mean as well. We also know from here that size of one standard deviation in our data is 16.5%, which means that if we go 16.5% to the left of the mean, or one standard deviation from the left of the mean, say at this point, the value that we will arrive at would be minus 4.5, which is 12 minus 16.5. What we are interested in is to locate a value of 0, which must be somewhere here then. The question now is, how many standard deviations away from the mean is this point? We can find that out very easily. If 16.5% constitutes one standard deviation, this will mean that 1% is going to constitute 1 over 16.5 standard deviations. What distance are we interested in? We are interested in this distance, which is this value of 0 here and the mean value of 12 here. So the distance is 12 percentage points. So 12 percentage points are going to constitute 1 over 16.5 multiplied by 12. That is 0.73 standard deviations. And in our case, 0.73 standard deviations to the left of the mean. So we could say that the distance is minus 0.73 standard deviations. What we have done is that we have calculated a quantity known as the standardized normal variate, which we give a name Z, and is calculated as the desired value, which in our case is 0, and we have given it a name X to generalize the things, minus the mean value mu, which in our case is 12, divided by the size of one standard deviation, which in our case is 16.5. So if we plug in the numbers, 0 minus 12 divided by 16.5, we are going to get the same thing, minus 0.73. So what we have found out up until this point is that the index value of 0 is 0.73 standard deviations to the left of the mean. Now what we want to find out is the probability of obtaining such a Z value, which we write as this. In terms of the normal distribution curve, what we are interested in is finding out this area, the probability of obtaining a value of Z or less. We can do that very easily by going to a cumulative normal distribution table. Let me show you a cumulative normal distribution table. This is a cumulative normal distribution table. You see two columns here, column D and column N of D. Where D stands for deviation, we have used the letter Z instead of D. It does not matter. The choice of letter does not matter as long as we know what it means. So in our context, this will mean Z and n of z. D, as you can see, begins with -3, and if full table were on the view, you would see that D would go on till 3 standard deviations to the right of the mean as well. The starting point is -3 standard deviations, that is 3 standard deviations from the left of the mean, and it will go on till 3 standard deviations to the right of the mean. And the corresponding column is giving us the probabilities. What is our Z value? Our Z value is -0.73. So let us try to locate that. In this column here, you see there is a value for -0.72, which is equal to 0.2358. And we also have a value of -0.74. The corresponding value of the probability is 0.2297. But we need a value of -0.73. So this must be somewhere between these two values. What we can do is we can calculate an average. So the value against -0.72, let's look at it again, is 0.2358. We can write it here. And we are going to add the value of -0.74, which is 0.2297 here. And we take a simple average of the two numbers. Let us try to do it by invoking a calculator. So we have a calculator program here. Let us calculate the average. 0.2358 plus 0.2297 divided by 2. This gives us a value of 0.23275. So let us write that down there. 0.23275. This means that the market has been down 23.275% of the times during this time frame since 1945. 0.23275 is this area here. So this was simple, isn't it? If you wanted to do the same thing in Excel, you would have used the norm_dist function. In the next video, we are going to solve the same problem using Excel. Now let us change the problem a little bit. Let us look at this one. Suppose the above question is rephrased to say that since 1945, the market has been down 23.35% times. So this time we know the probability already. The question is, what would the index value have to be for the market to be down? We already know the answer from the previous question, that the index value would have to be 0. So in this case, we are working backwards. We are working with the probability. We know from the table also that to get the probability value of 23%, the value of Z would be -0.73. So we start working with that. Let us write down the standard normal variate here once again. But this time around, we know the value of Z, that is where we are starting from, and we are essentially solving for the value of X, which we already know should be 0. So Z is -0.73 is equal to X minus the mean value of 12 divided by the standard deviation 16.5. So we can solve this for X. -0.73, this guy is going to go there and get multiplied, and this guy is going to go to the other side as well and get added. This is going to leave us with X on the right hand side. Let us invoke the calculator and see what we get. minus 0.73 multiplied with 16.5 is equal to this, and we add plus 12. So what we get here is minus 0.045. Let us write that here. Which is a little bit away from 0. So we can say it is approximately 0. And the little difference that you see is probably a rounding off error. If you want to do the same thing in Excel, you can use the norm_inv function. We will do that in the next video.